All right, this time we're going to be doing the second fundamental theorem. We already learned the first fundamental theorem, that was day 1. We learned about average value for day 2, and now we're doing the second FTC. Now, the book's formula on page 289 is right there. And I just think that it's sort of lame, to be honest. I love our textbook. I think it's the best calc textbook on the market, but this is not the greatest section. First of all, you can tell that you're doing the second fundamental theorem when you see that you're taking the derivative of an antiderivative, which just seems counterproductive at the very least. It almost seems like you're going around in circles, like Winnie the Pooh and Piglet heading back through the 100-acre wood and they get back to the log again and they're like, weren't we just here? Why would you want to take the derivative of an integral? That's like hitting square root and squared back and forth on a calculator. It's like it gets you just back to the start. But you know what? You do kind of get back to the start. It looks like the answer is what you kind of had before you did the process, except the letters have changed. All right. When I first learned this as a student, I was like, all right, I'll get my A on the quiz and the test, but I really didn't understand it. I didn't know why we learned it. I didn't know why it was useful. I really didn't even know why it worked. Once I became a teacher, I knew I had to figure it out in a hurry and be able to explain why it worked. So one day I just sort of sat down on my own and really kind of thought it through, and here's what I came up with. I came up with an improved method of doing this. It's not anything anybody else hasn't thought of, I'm sure, but I just kind of put my steps into everyday language. So here's what you want to do. Okay, step 1, you want to replace your t with the upper limit of integration. So notice that the t goes away and the x just kind of plops in there. Right, that looks great. Step 2, multiply this result by the derivative of the upper limit. So again, here's your result here, this f of x. Multiply that by the derivative of x. Of course, the derivative of x is 1. They don't show that, but there is a times 1 there. Okay, step 3, you're simply going to subtract, so minus. And finally, step 4, repeat steps 1 and 2, but use the lower limit. Okay, so you put the lower limit in again, and that would be minus, okay, and then f of a. But the reason you don't see this written is the derivative of a, since a is a constant, would be 0. And multiplying by 0 kills this all off. And you don't see the times 1 either. And so the book just calls it f of x. The thing that bothers me about this is all the problems that the book made are just super simple. They just put an x on the top and they put a number on the bottom, like a 1 or a 2 or a 0. And so what students think is, oh, whenever I see this, I just change t to x and I just move on. And that's not what it is. It's so much more detailed than that. And there's reasons why we learn and use this too, that I never knew myself on it until I was even through college. All right, so we'll try some examples. We'll get you guys ahead of me here. Use the second FTC to find the derivative. We're finding the derivative of an integral. That is curious. And there's a third wheel, there's a third letter, there's a t as well. So you get x, y's, and t's. That's a sure sign. Even if the directions didn't say use the second fundamental theorem, I would know that's what I need. All right, so I'm going to follow the steps. Step 1 is replace t with the upper limit of integration. So the 8's going to go in there. And that's going to turn this into 1 over 1 minus 8 squared. Okay, step 2, multiply this result by the derivative of the upper limit. What's the derivative of 8? Oh, it's 0. Which means I just wasted my time. I didn't have to write any of that stuff. Oh, well, it was fun. Okay, step 3, minus. And now we repeat this with the lower limit. So we'll put sine of x in instead of t. It's still going to get squared though. So we have 1 over 1 minus sine squared x. And then multiply this result by the derivative of the lower limit. This actually does have a derivative. The derivative of sine of x is cosine of x. I'm running out of room, so I'll just put that on the top. Okay, I'm ready to write my final answer. This obviously is 0, so it's not there. The negative is in front, so we have negative cosine of x over, oh, you know what? Golden sheet. You know what 1 minus sine squared is, I hope. It's cosine squared. And you can cancel a cosine away from each one of them. And so the answer is negative 1 over cosine of x, also known as negative secant of x. So again, I'm going to give you problems that are a little more meaty than what the textbook does. They're just replacing t's with x's, which is just so stupid. Now let's try a few more. All right, so I noticed I'm supposed to take the derivative of an integral, and this problem has x's, y's, and t's. So that's definitely second fundamental theorem if it wasn't told to you already. So let's do the 4-step method. Step 1 is to, instead of where the t is, and this is getting a little more complex, so I'm just going to kind of do this. Take the t out, let's have a parentheses there, and put the upper limit in. So this 4x squared is going to dive in there. And it will get squared. Notice the 5 is not being squared, just the 4x squared part. And the minus 2, of course, is not being squared either. Okay, multiply this result by the derivative of the upper limit. So the derivative of 4x squared will be times 8x. So I'll get to that. Minus, and then I think you can see that you don't have to bother with the rest. Sure, you could plug the 10 in, but why would you want to do that? Because eventually you're going to multiply by 0, which is the derivative. So that's going to be a big bunch of nothing. And so you don't have to do it. In fact, if you come across a problem where both the upper and lower limits of integration are both constants, that's just 0 minus 0, which would be 0. In fact, you root for problems where one of them is a constant because you only have to do half the work. If I wanted to be tougher on you, I'd make them both, problems with x's in them, which I'm sure I will eventually. All right, let's finish this up and kind of make it look nice. I've got 4x squared times 4x squared. That's 16x to the 4th. Multiply that by 5. 5 times 16 is 80. So 80x to the 4th minus 2. But then it's times 8x. So I have two choices. I could distribute it through, which I think I will. Okay, so there's one way to write the answer. Or I guess I could take this over here, and in the parentheses I could factor out a 2. That would make this 8x into a 16x. And then these numbers in the parentheses would be cut in half, so I'd have 40x to the 4th minus 1. That would be fine as well. I mean, really, even this answer is okay. It's just a little weird because it's kind of partially factored, partially not. I think you either want to full out factor it or don't factor it at all. Use distributive property. That is the derivative of the original. What do you know? Your teacher put x's in both limits of integration, upper and lower. Yeah. All right. Let's start with the upper first. Okay, we'll figure out what that is momentarily. Multiply this result by the derivative of the upper limit. So we're going to multiply that by 3. I think I'm going to try to squeeze the 3 in front. I'll just move this over slightly and put a 3 in front. Excellent. Okay, minus. And I'll repeat the process once again. This time the 2x to the 5th is going in. And we multiply that result by the derivative of the lower limit. That's going to be 10x to the 4th. Again, I'm going to slide that into the front. And now all I have to do is just some serious simplification, and hopefully this will work out. 3, 2, 1. We'll start by squaring 3x. 3x times 3x is 9x squared times 4. That's 36x squared. Minus 21x plus 1. That is going to get tripled. So we'll have 108x squared minus 63x plus 3. Okay, awesome. Okay, over to the red. 2x to the 5th times 2x to the 5th is 4x to the 10th times 4 is 16x to the 10th. minus 14x to the fifth plus 1. That's being multiplied by, I'm going to call it negative 10x to the fourth. That's going to change the sign, so we're going to have negative 150, negative 160, I mean, x to the 14th. Negative times negative plus 140, x to the 9th, minus 10x to the 4th. And since absolutely none of those are like terms, I'm just going to circle the whole thing and turn it into my final answer. I suppose I could put it in descending order, but nah, I'm good. All right, we're finding f prime. We're taking the derivative of an integral. So it's going to be second fundamental theorem with the t's in there and everything. So we're going to start out doing what we know. We're going to plug the 7x in. You know what? I know I'm going to be multiplying by the derivative of that. I know that's a 7. I'm going to leave a space for that in front first. And now I'll do the rest. Okay, in goes the 7x. Okay, steps 1 and 2 are complete. Step 3, subtract. Awesome. And finally, step 4. Repeat steps 1 and 2 with a lower limit of integration, the 3x to the third, whose derivative happens to be 9x squared. I'm going to lead off with that. Just slowly becoming more efficient. All right, so the 3x to the third gets dumped in to both of the parentheses where the t's used to be. And now it's just up to me to simplify. All right, so I've got that. Now for some distributive property. And I'll write my final answer in descending order. I do notice that I can combine a couple like terms. There are a pair of squares. Everything else is different. So here's what I'll have. All right. Now, by now you're probably thinking, okay, great, this is interesting, but who cares and why do we do this? Why does this even work? And why is it important? And I'm going to do my best to explain that right now. So first off, I want to take that final answer that we got and I want to save it so that once we prove this, I can come back and compare. Okay, so why in the world does this even work? I'm going to repeat one more time. But this time I'm going to pretend like I've never seen the second fundamental theorem of calculus in my life. So obviously if I didn't know about that, I would have to integrate it first. All right, so here goes. F of x is equal to, all right, I got to go up by a power, so 2/3 t cubed. Oh, this is already going to be nasty. Oh my gosh, why am I proving this? Plus 5/2 t squared. Maybe I should just memorize the 4-step method instead. Minus 4t. Okay, it's been integrated. Yay. Okay, 7x, in you go. So 7x times 7x times 7x is 343x to the third times 2/3. I'm going to leave that unmultiplied just for now. Okay, 7x times 7x is 49x squared times 5/2. 5/2 times 49x squared. This is really not very fun. 4 times 7x is just minus 28x. It's not too bad. Okay, that's the first part. Then we have to go minus, and we'll repeat the process with the 3x cubed, going in all 3 times. So I just have to stay patient with this. 3x cubed times 3x cubed times 3x cubed is 27x to the 9th times 2/3. 2/3 times 27x to the 9th. Okay. 3x to the 3rd squared would be 9x to the 6th times 5/2. Okay, 5/2 times 9x to the 6th. And finally, 4 times 3x to the 3rd is 12x to the 3rd, and there's a minus in front of it. Okay, cool. Not cool. All right, so that's f of x. Now, I'm going to take this and recopy it because I don't want f of x. Remember, the directions said find f prime of x. So now I have to take the derivative of that whole thing. And remember that there is a minus in front here, so it is going to distribute through first and change all the signs. And then if I want to combine like terms, I can. If not, I'll just do it later. Okay, remember, this was f of x, so like I said, we have to take the derivative now to find f prime of x, which is what we were asked for originally. All right, derivative. The reason I didn't multiply was I realized that this 3 was going to cancel this 3 out. Same thing here, this 2 would cancel this 2 and so forth. So that's just going to be 2 times 343. That'll be 686 x squared. Again, same thing, these 2's will cancel. 49 times 5 happens to be 245x. And the derivative of minus 28x is minus 28. Okay, here, 9 times 2/3. 2/3 of 9 is 6. 6 times 27 is going to be negative 162 x to the 8th, because it's going to go down by a power. 6 times 5 halves, I can cancel that. That's going to be 5 times 3, 15. 15 times 9 is 135, but whoop, it's negative. So minus 135 x to the 5th, because it was 6, then it went down by a power. There's chances for mistakes left and right here. Finally, I have negative times negative. I'm going to write a plus before I forget. And the derivative of 12x to the 3rd, that might be the easiest thing I do here. That's 36x squared. All right, let's get some like terms together. 686 and 36 is going to add up to 722. So if we put this in descending order, let's see, the 8th powers come first. Negative 162x to the 8th. Then the 5ths. Then the squareds, what did I say that was again? 722. So that's both of those combined, plus 245x, minus 28. And that's my answer. And hopefully that looks familiar because it's the exact same answer that I copied from my earlier work when I did the 4-step method, more formally known as second fundamental theorem. So second fundamental theorem is a major shortcut. But sometimes not only is it a shortcut, it's the only cut. You're probably thinking, what do you mean the only cut? Well, what if this was like to the 10th power and you couldn't do a u sub because you can't, and you don't want to FOIL it out, and what if it was to the 101st? No, you definitely don't want to FOIL it out. If you don't know second fundamental theorem, there's no way to get it. You just simply can't do the problem. So sometimes you have to use it. So anyway, that's what it is, and that's why it works. And again, I think that my 4-step method is a little better explanation than just the book's little box that they have there on the one page.